Hey everybody, I'm back. I don't know if you were watching our previous stream. I apologize. Right now we are in balmy upstate New York where the temperature outside is about 98, but it feels like 112. And it looks like we just had a power outage, very briefly. But if you have a power outage, that means that the Mac gets turned off, the internet gets cut out, and our entire stream just gets shot. So, unfortunately, we now have a bifurcated Algebra 2 review stream. I had gotten all the way up to problem 21. So let's review what's going on with problem 21. Let's take a look at the board. The profit function p of x is found by subtracting the cost function c of x from the revenue function r of x. Which function below represents the cost function given p of x equals negative 15x squared plus 600x plus 60 and r of x equals negative 0.4x squared plus 130x plus 1200? All right, so let's take a look, hopefully, at how this problem is done. Now keep in mind, right, what we are looking for is we're looking for the cost function given that we have the profit and the revenue. We were told that the profit function is equal to the revenue function minus the cost function. But we're given the profit and the revenue. We know these two and we want to know this one. So what I'm going to do is I'm going to throw this one on this side, making it positive, throw this one on that side, making it negative, and what I find is that the cost function then is the revenue function minus the profit function. And now I'm in business, right? Because I know that the revenue function is negative 0.4x squared plus 130x plus 1200 minus the profit function, which is negative 15x squared plus 600x plus 60. And you did a lot of problems kind of like this in Algebra 1, except they weren't quite this ugly. And we just need to distribute this negative through the parentheses, right? We'll get negative 0.4x squared plus 130x plus 1200. You'd think I would have given myself a little bit more room, but I didn't. And then I just put that random line there. Let me see if I can move this. Nope, can't move it. All right, so then when I distribute the negative, I'll get plus 15x squared minus 600x minus 60. All right. So now I can combine that negative 0.4x squared with that positive 15x squared. That'll give me 14.6x squared. I have 130x minus 600x, which gives me negative 470x. And then I have 1200 minus 60, which gives me positive 1140. I know that I stole a lot of room from 22, but that's okay. So 14.6x squared minus 470x plus 1140, and that's choice 3, and we're back in business. All right. So again, my apologies for the power outage. I can't promise it's not going to happen again, given that probably everybody is running 2 or 3 air conditioners right now in the greater upstate New York region. All right, let's take a look at problem number 22. What is the remainder when 4x cubed minus 3x plus 3 is divided by x minus 2? Now, we already talked about the remainder theorem, right? And we talked about that, a little while ago. But remember that if I want to know what the remainder is when I divide a polynomial by something of the form like x minus 2, all I have to do is evaluate this polynomial at sort of the zero of this binomial. So I need to figure out what this is evaluated when x is equal to 2. Literally, the remainder when x is equal to 2 will be 4 times 2 cubed minus 3 times 2 plus 3. All of that is equal to 29. And there's your remainder. Now, it is possible that what they kind of expected you to do in this is to actually do the polynomial long division. All right? I'm not sure. But it's very, very similar to, what was it, question number 14 that we had earlier. All right, let's keep going. I'm a little bit worried about the power right now. All right, my second least favorite problem on this test. Maybe this one actually beats the previous one. Problem number 23. The parabola with equation 12 times y plus 1 is equal to x minus 4 squared has, number 1, a vertex at 4, 2, number 2, a focus at 4 divided by 4, negative 1, a directrix of y equals negative 4, and 4 units between the focus and the vertex. All right, so again, I sincerely don't like this question. One thing that is good, not for you guys, but for future people that are taking this course in New York State, is that the new standards will not include questions like this, or at least in theory they won't. All right. So the first thing I'm going to do is I'm going to rearrange this equation a little bit, and I'm going to put that 12 over on the other side. So I'm going to have y plus 1 is equal to 1/12 times x minus 4 quantity squared. So I divide by 12 on both sides, and I get something that looks like that. Now, one thing right away that this tells me is that the vertex of this parabola, right, the vertex is at 4, negative 1, right? So that means choice 1 is out, and that means choice 2 is out, because the focus and the vertex are not the same thing, all right? And they never will be, all right? So my vertex is at 4, negative 1. So how do I then decide between these two? And quite frankly, I'm not really sure how you're supposed to do this problem unless your teacher got into something very, very specific, okay? And that's the following. If I have, let's say, a parabola, right? And the whole idea is that I've got this focus, I've got a horizontal line or a vertical line. In this case, it's a horizontal line called the directrix. And then I've got my vertex halfway between the two, right? And let's say this is a parabola that opens upwards like this, all right? This distance between the focus and the vertex, also between the vertex and the directrix, I like to call f, all right? I like to call it the focal distance, all right? And what's always true is that if we're in this kind of form, all right, then we will always have something like this. Y minus k is equal to 1 over 4f times x minus h squared. And this could be positive or negative depending on how the parabola opens. All right. So the focal distance, right, is, that distance, all right? The distance between the focus and the vertex. Now, if I kind of compare these two forms, then I can see that f would have to be equal to 3, all right? That allows me to eliminate this. 4 units between the focus and the vertex. Well, the distance between the focus and the vertex has to be 3 units, not 4 units. So that means that the directrix has to be at y equals negative 4. All right. That is definitely not the purpose of the standard that actually shows up in the Common Core standards, but it is the only way that I think that you can do this problem. Let's take a look at number 24. Jay is training for a bike race over 15 weeks. At the end of the first week, he has ridden 10 miles, and he is planning to increase his weekly distance by 9% each week. Approximately how many total miles will he have ridden from the beginning of his training to the end of the 15th week? Well, what I like to do in problems like this, and what I will always encourage you to do in problems like this, is to start by just writing out how far he's gone, right? So let's see. In the first week, he's ridden 10 miles, right? And he's planning to increase his weekly distance by 9% each week. So the second week, he'll be going 10 times 1.09. The third week, he will go 10 times 1.09 squared. And then 10 times 1.09 to the third, etc. Until what? at the end of his 15th week, be careful here, right, he will be, whoops, at 10 times 1.09 to the 14th. Okay, so this then is a geometric series, all right? Now you could actually take your calculator out and actually just put this all in and add it up, right? But there's this formula, it's actually on your formula sheet, that says that the sum of a geometric series is a1 minus a1 times r to the n, all divided by 1 minus r. In this case, a1 is 10, so we'd have 10 minus 10. The common ratio is that 1.09. N is the number of terms, so that's actually raised to the 15th, all divided by 1 minus 1.09. And that's just an issue of putting that into the calculator. It's just an issue of putting it into the calculator. And when we do that, what we end up getting is 293.609. And so, I love this. Approximately how many miles? Well, to the nearest thousandth, right? We go approximately 293.609 miles. I love the fact that they didn't just go 294 miles. We go approximately this far. It's absolutely crazy. All right, so let's keep going. Now I feel like we're getting a little bit of a lag in the video, so I apologize if for some reason like the volume is a little bit off, or not the volume, but the sound is a little bit off from the picture. I think that's a remnant of us kind of like losing power. But now we're going to go on to part 2 questions, but before we do that, let's just take a moment. I gotta refresh myself. Got to have a little bit of lemonade, got to get ready for our part 2s. Obviously the part 2 questions, right, on all of our math exams are 2-point problems. On Algebra 2, that doesn't mean much. They can really be quite beastly. Not the first one, thankfully. This one's not going to be too bad. We'll get to it in a moment, right? But in these kind of questions, right, you can get either 0, 1, or 2 points. And the only way you get 2 points is by doing everything absolutely perfectly and in the way that they specify. So you really have to watch out if they say solve something algebraically versus just, find an answer, etc., etc. Let me take one more drink of lemonade, and then we'll kind of launch into our first part 2 question. All right. Definitely needed on a day like today. I want to sympathize with all of my students out there who are in anywhere in New York. I think anywhere in New York today has been absolutely miserable. Even now at 7:30 at night, it's probably in the mid-90s out there with nearly 100% humidity. So it's dangerous levels of heat, all right? And that's why we lost power there for a moment. Let's take a look at problem 25. Given x is a real number, write the expression in simplest a plus bi form. All right, so x is a real number. We assume that I is the imaginary base, and the most important thing to know when you're dealing with a problem like this is the fact that I squared is equal to -1. Okay, so given that, what we're going to now do is a little bit of basic algebra, and I'm going to first multiply these two binomials out. So let's start with that. Just a little foiling action. So we're going to have x times 3, and we're going to get 3x. And then x times -2xi, and that's going to be -2x squared times I. Now we're going to get 2i times 3, so that's going to be 6i. And then 2i times -2xi, so that's going to be -4xi squared plus 2x squared I. And maybe make that look like a x squared. Now, one thing that I noticed right away is that I have a -2x squared I and a +2x squared I. So these two things are just going to cancel, right? And that's going to leave me with 3x plus 6i. And now how do I deal with this? Well, that I squared, we always want to replace with a negative 1. All right? And that means I'm going to have a negative here and a negative here. And those will then turn that positive, and I'll get 3x plus 6i plus 4x. And now I can combine the 3x and the 4x, and that'll give me 7x plus 6i. Okay? Now, you might say, why didn't they just give me a normal, like, complex number product or something like that? Well, they didn't do that because you could do all of that on your calculator. So they throw the x's in to force you to be able to, number one, foil something out, but also to recognize the fact that I squared is equal to negative 1. All right, let's take a look at the next problem. Number 26. Solve 3.8 e to the 1.5t equals 16 algebraically for t to the nearest hundredth. All right, so this is really critical, right? They tell us that we must solve this problem algebraically. So let me just write this equation larger so that you can see things a bit better. 3.8 e to the 1.5t is equal to 16. All right. Now, this won't be the last time that we'll solve an exponential equation on this test. All right. In order to solve it, right, think about this. We've got e to the 1.5t times 3.8 is equal to 16. I just want to apply inverses. So the first thing I'm going to do is I'm going to divide both sides by 3.8. Now, what I'm not going to do at this point is I'm not going to actually figure out what 16 divided by 3.8 is. If 16 divided by 3.8 was a nice number, like if it was 16 divided by 4, sure, yeah, 4, okay? No worries. 16 divided by 3.8 is a little bit messy, all right? So for right now, I'm just going to kind of hang out at e to the 1.5t is equal to 16 divided by 3.8. Now, how do I get rid of that exponential? Well, what I want to do is I want to do the log base e of both sides, and that is the natural logarithm. All right, so the natural logarithm is the inverse of the exponential. All right, so when we do that, they cancel, and we're left with 1.5t. Oh, that almost looks like a 5, but not really. Let's try it again. 1.5t is equal to the natural logarithm of 16 divided by 3.8, which is whatever it is. And I don't really care right now because I'm going to do one more step and then I'm going to get my final answer all at once, right? So t is equal to all of that. So now I'll just grab the calculator, right? And I will just do Control e to the x. We'll have 16 divided by 3.8, whoops, within the logarithm, and then divided by 1.5. And this avoids any kind of rounding issues as I'm going along, right? Now again, I could do 16 divided by 3.8, get a messy decimal. Then I could do the logarithm of that messy decimal, get another messy decimal. Then I divide by 1.5 and get my final answer. But doing it this way, right, allows me to only have to round and write down really messy stuff right at the end. And they want it to the nearest hundredth. We want to watch out for that, right? This is only 2 points. So if I round this to the nearest tenth or round it to the nearest thousandth, right, I'm going to lose a point, which is, of course, a bit unfortunate. All right. So I simply get 0.96. All right. And that's that. Okay. Oh, we have another one on this page. It's very rare that they put more than one free response problem on a page, but here we go. Let's take a look at 27. In an attempt to get the student body opinion of a new dress code, members of the statistics class surveyed the students of the first period computer science class. Explain statistical bias in the method of data collection. All right, So this is kind of classic, right? We're trying to figure out, right, the whole student's body's opinion on a new dress code, right? But we just end up surveying the students in the first period computer science class. Explain statistical bias in the method of the data collection. All right, well, forgive me if I don't write down a bunch of messy stuff here right now. Let's just talk about the statistical bias, right? The plain fact is, because we only are surveying students in one particular class, they are likely not representative of the school as a whole. Number one, students that are in computer science might have more uniform opinions about a dress code, either pro or against, right, than the student body in general. Likewise, they might all come from a given grade. Maybe everyone in 10th grade takes computer science, right? So we're not getting the full breadth of the student body, and that's the point. So any kind of explanation that really gets into the fact that the students that are just taken from a particular course don't represent the entire student body will get you 2 points here. All right, so without having to write all that mess down, let's move on. Okay, let me make this one. Actually, we'll keep it there, and then I'll kind of, then I'll zoom out for a second. 28. Sketch a graph of polynomial p of x given the criteria below. First off, p of x has zeros only at -5, +1, and +4. As x heads towards infinity, p of x heads towards -infinity. And as x heads towards -infinity, p of x heads towards -infinity. All right, so let's talk about this problem. I actually really like this one. First, let's take care of the easy part. Let's plot the zeros only at -5, 1, and 4. All right, this is simple enough. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let me just, I don't know, let's go to 200%. Ah, there we go, that's a little bit better. So we've got a 0 at -5. We've got a 0 at 1, and we've got a 0 at 4, and that's it. Those are the only 3 locations that this graph can touch the x-axis. Now, these other 2 conditions, right, as x goes to infinity, p of x goes to -infinity, and now it's rather small, I apologize. And as x goes to -infinity, p of x goes to -infinity means that as the graph heads this way, it's got to be pointing downward. And as the graph heads this way, it has to be pointing downwards. Now, what's weird about that is if you start sketching this particular polynomial the way that you normally would, it might look something like this. And the problem with that is that that then contradicts one of those 2 statements, right? It means that this one, the first one, as x heads towards infinity, p of x heads towards -infinity, isn't true, right? So you might say, well, I can fix that, right? Because then I'll just go like this, right? But the problem is that would introduce an extra 0, right? So how do we make it so that both ends point down, and yet it only hits the x-axis at those 3 locations? Well, the key will be at one of the 3 locations, and now of course I have to carefully erase this, at one of those 3 locations, I need the graph to be tangent to the x-axis. All right, it's got to be tangent to the x-axis. Does it matter which of the 3 locations? No, it doesn't, right? So for instance, I could make it look like this. Make sure to make your curve nice and smooth. No straight lines, okay? No straight lines. Likewise, I could have my tangent point on my first one. I could do something like this. And that would be fine as well. Or it could be the third one. Now, by the way, if you're really on top of things, you could also make it tangent at all 3 of the points, and it would also achieve this look. but it has to be tangent at either one of the zeros or three of the zeros. If you do two of the zeros tangent, then you get that kind of opposite, the tails heading in opposite directions. All right, but that's basically it. Pretty easy. All right, let me change back to blue. That's my preferred color. And let's take a look at number 29. The height above ground of a Ferris wheel car can be modeled by the function h of t equals negative 103.5 cosine of 2 pi t over 5 plus 108.5, where h is measured in feet and t is measured in minutes. State the period of the function and describe what the period represents in this context. All right, great. So there is a lot going on in this problem that doesn't matter. The negative 103.5, this 108.5. I'm going to make this thing fit my width so I can see it a little bit better. Ah, there we go. Nice. Right? None of that is relevant. We just want to know what the period is. Now, in the function, right, we've got a 2 pi over 5 that's multiplying t. And that's what's known as the frequency. So I typically use the word b, or the word, how about the letter? B as frequency is 2 pi over 5. All right. The period, p, is related to the frequency b by the following equation. B times p is equal to 2 pi. That means that I can do 2 pi over 5 times the period is equal to 2 pi. And now if I multiply by 5 over 2 pi on both sides, right, I get the 2 pi's cancel, and my period is 5, right? So the period is equal to 5. Great. That's 1 out of 2 points. State the period. The period is 5, right? Now describe what the period represents in this context, right? Well, the period always has the same units as whatever the units of the input variable is, and that is time measured in minutes. So the period is 5 minutes. But what is the period? The period is how long it takes for the periodic phenomenon to repeat itself. Now, what are we talking about here? We're talking about a Ferris wheel car that is moving around a Ferris wheel, right? And we're measuring its height. So what does that 5 represent? It represents that it takes 5 minutes for the Ferris wheel to make one complete revolution. That's it. All right. Another problem on the same page. Let's take a look at problem 30. Solve algebraically for all values of x. 8 divided by x plus 5 minus 3 divided by x is equal to 5. I think that this is a pretty beefy 2-point problem, me personally, right? But you should have spent some time solving equations that involve fractions. Now, various teachers teach this in various ways, which is one of the challenging things to do when you do one of these reviews. When I teach this, I teach it as clearing the denominators. So I look at a denominator of x plus 5, a denominator of x. I know only an x plus 5 will cancel an x plus 5, and only an x will cancel an x. So what I'm going to do is I'm going to start by multiplying both sides of this equation by x times x plus 5. And again, real important that we multiply both sides of the equation. All right? Now, once I do that, right, what I'm going to do is I'm going to distribute this to both of these things. So I'll have x times x plus 5, and if it makes you feel better, put that over 1, times 8 over x plus 5, minus x times x plus 5 over 1 times 3 over x. And on this side, I can actually distribute that 5x squared and 25x. All right, on this side, the x plus 5 cancels an x plus 5, and x cancels an x, and now I'll have 8x. Here I'm going to have negative 3 distributing through that parentheses, so that'll be minus 3x minus 15 is equal to 5x squared plus 25x. And notice what I've achieved right now, right? By multiplying through by x times x plus 5, which would be the least common denominator of these two fractions, what I've done is I've eliminated all of the fractions. Now, because I've got an x squared, I want to get everything equal to 0 and either use the quadratic formula, completing the square, or factoring to solve for x. I think because the x squared is sitting on the right-hand side, I'm going to move all of this over to this side. First, maybe I will simplify the 8x minus the 3x, though. All right, so all of that's going to be 5x minus 15 is equal to 5x squared plus 25x. So I'll subtract a 5x from both sides, and I'll add a 15 to both sides. And finally, I have everything equal to 0. 0 equals 5x squared plus 20x plus 15. Now, you could definitely use the quadratic formula to solve this, but notice that there's a common factor of 5 in all of these things. So what I'm going to do, because it's an equation, is I'm just going to divide this side of the equation by 5 and this side of the equation by 5, giving me 0 equals x squared plus 4x plus 3. And now this should be fairly easy to factor. X plus 3 times x plus 1, giving me two solutions. I'm going to write them up here because I want to be able to look at the original equation once I have them. All right. So I've got my two solutions, x equals negative 3 and x equals negative 1. Now, you have to be careful when you're solving equations that have fractions in them because they could have extraneous roots. And the way that you tell whether they're extraneous or not is not by going through an entire check. Don't do that. Just take a look at both solutions and ask yourself, does it cause either of the denominators to be equal to 0? Well, the only two values of x that we'd have to throw away would be x equals negative 5, that would make that denominator equal to 0, and x equals 0, that would be a problem here. Neither one of those shows up here, so both of those are perfectly good solutions. Now, again, I find this to be an awful lot of work for a 2-point problem, and it would be even more insane if after all of this, there was also an extraneous root. I mean, if that doesn't deserve 4 points, I don't know what would. All right, but let's move on. Let's take a look at 31. The transportation methods used by upperclassmen at Calhoun High School are summarized below. All right, so we have these upperclassmen, right? And they are juniors and seniors, and they either drive or they take the bus or they walk. Are the events being a junior and driving to school independent? Use statistical evidence, justify your answer. Now, right, this idea, events being independent, again, there are multiple ways of checking for independence, all right? And again, it's tricky because it's like I sort of want to do one or I sort of want to do the other. So first thing I'm going to do is I'm going to check using what's called the product test for independence. So two events, A and B, are independent if the following is true. If P of A and B equals P of A times P of B, if this is true, then they are independent. And that's often the easiest way of doing this problem. So if the probability of A and B occurring together is equal to the probability of A times the probability of B, then they are independent. And if they are different, then they are not independent. All right, so the first thing that we've just got to be able to figure out these probabilities, and part of that is knowing the denominator in everything, right? And the denominator in everything for right now is the total number of students, which they didn't give us. So we have to take our calculator out and do 58 plus 75 plus 12 plus 81 plus 39 plus 12, and that gives us in total 277 students. So a nice, ugly number, 277 students. Just wanted to make sure. All right. So let's kind of figure some things out. Being a junior and driving to school. So let's first figure out the probability that one is a junior and drives to school, right? That's right here. So the probability of being a junior and driving to school is 58 out of 277, and I'm going to just give some decimals there so that we have them. So that is 0.209386, and I'm going kind of grisly there. I'm going to give a lot of decimals. Now, let's figure out the probability that someone's a junior, figure out the probability that somebody drives to school, right, etc. Now, to figure out the probability that somebody's a junior, I would have to add all of these together, but that's easy enough, right? The probability that somebody is a junior, there are 145 juniors out of 277. The probability that somebody drives to school, I would then add these up, and that is 139 divided by 277. And so if I then did P of J times P of D, I would get 145 over 277 times 139 over 277. And that would all equal 0.262678. Let me circle those two probabilities. Right? Now notice, right? Notice that those aren't equal to each other. So it fails the test for independence. So we would say no because P of J and D doesn't equal P of J times P of D. So that is one way of doing this problem, and it's most likely the way that you did it quite a bit in class, right? Because it's very straightforward, it's very easy. The thing that I don't particularly like about this method is that it doesn't get to the heart of independence, which is, does one event change the probability that another one happens, right? And so to do that, what I would actually do is I would calculate the probability that one drives to school, and then I would calculate the probability that one drives to school given that they are a junior, and see if those two probabilities are the same, right? So that's another way to do it. So just really quick, another way to do it is to figure out the probability that one drives to school, and we kind of already have that. That is 139 out of 277. And that's 0.501805. And let's demystify this for a second, right? You know, what this really just says is that roughly 50% of all the students drive to school, okay? So then the question becomes, what is the probability that one drives to school given that they're a junior? Now to do that conditional probability problem, right, what we do is that we only consider the juniors, right? We only consider the juniors. And remember, there are 145 juniors, and there are 58 of them that drive to school. So what we would do in that situation is we would do, right, 58 divided by 145, which is exactly 0.4. That's convenient. And now think about that. That means that only 40% of all the juniors drive to school. And that means driving to school is not independent of being a junior. Being a junior changes the probability that you're going to drive to school. It's less likely. And again, you know, if you go to almost any high school, you know that, right? You know, there's some juniors that drive to school, some juniors that don't drive to school, whereas a lot of seniors end up driving to school. All right, so again, because these two are not the same, you would say no. And then you'd say, because the probability of, D does not equal the probability of D given J. Whichever of those feels more natural to you, that's what you should go with. All right, let's keep going. All right, let's take a look at problem 32. Can f of x equals x cubed plus 7 be classified as an odd function? Justify your answer. All right, well, so functions get classified in all sorts of ways, right? You got your linear functions, your quadratic functions, your absolute value functions, your trigonometric functions. And then we have these two special types of functions called even functions and odd functions, right? Odd functions, ooh, come on, pen. Let's try that again. An odd function is a function that f of negative x is always equal to negative f of x. As a side note that has very little to do with this problem, but you never know, it might come up on Wednesday's exam, an even function is where f of negative x is equal to f of x. Now, what does this really mean with even and odd functions? Well, what it means is with an odd function, when you put in an opposite input, you get an opposite output. With an even function, right, when you put in an opposite input, you get the same output, right? Even functions are real simple. Something like f of x equals x squared is an even function, or f of x equals the absolute value of x is an even function, because neither of those functions care whether the x that goes in is like positive 3 or negative 3. You get the same answer. Odd functions, though, will give you opposite answers for opposite values. So the first thing I would do in this particular problem is I would just test two inputs that have the same absolute value but different signs. So what I would do is I would do the following. Let's figure out what f of 2 is. 2 cubed plus 7, that would be 8 plus 7, and that would be 15. F of negative 2 would be negative 2 cubed plus 7. That would be negative 8 plus 7, and that's negative 1. Now, if this was an odd function, then these two outputs should have the same absolute value, but just different signs. And they don't. And it should be true no matter what two opposites we pick. And since we found that with 2 and negative 2, they don't give opposite outputs, the answer is no. And we don't need to do anything to justify it other than f of negative 2 does not equal negative f of 2. All right? It's as simple as that. Now, some of you may have memorized that both even and odd functions have particular types of symmetry. Even functions have beautiful symmetry. They're symmetric across the y-axis. You could just flip them across the y-axis and they will land on top of each other. Odd functions have symmetry about the origin, 180-degree rotational symmetry about the origin. So if you actually did a little sketch of this graph, and remember this is the graph f of x equals x cubed plus 7, you'd see something that looks like this. 1, 2, 3, 4, 5, 6, 7. It would look a lot like this. And that doesn't have symmetry about the origin. In other words, if I took this graph and I rotated it about this point, the origin, it wouldn't land on itself. So one way of answering this question is to draw a sketch of the graph, doesn't have to be beautiful, and just say, no, it doesn't have symmetry about the origin. All right, and that's that. All right, part 3. We're getting there. Let's take a little lemonade break for a moment. Right around 8 o'clock. Again, I'm really hoping that everyone is with us after our little power outage, staying cool, right? Hopefully by Wednesday it'll be a little bit cooler, although they're still talking about highs in the low 90s on Wednesday. By Thursday, once all the exams are over in New York State, then of course it's beautiful. It's like 75, but what are you going to do? Now, we're moving into part 4 questions. Now, part 4 questions tend to be, more involved, all right? Some of them are a single question, like what we're going to see in problem 33, and others happen to be like multi-part questions, each one of them worth a little bit of credit, all right? But there is a lot of opportunity for partial credit in these problems, and we start off with a classic that's quite a challenge. This was a tough Algebra 2 exam. My daughter took this exam last year, and I actually asked her about it, and she was like, yeah, that was pretty rough. And she did pretty well on it. I even talked to her about that normal distribution problem, and she's like, yeah, I think I wrote down 7. She didn't know what was going on it, which I understand. I don't think I did either. So let's take a look at problem 33. Solve the following system of equations algebraically for all values of x, y, and z. All right. Well, we haven't seen one like this for a while on the Algebra 2 exam. A system of 3 equations with 3 unknowns that must be solved algebraically. And I know there are some students and some teachers out there that opted to basically just learn how to do this kind of a problem on the calculator, right? The problem is, on a 4-point problem, if you do that, just use the calculator, you're going to get at most 2 points. And that's like if you give a little explanation of what you did and whatnot, right? Don't get me wrong. If there's no other way to do it, you don't remember how to do it algebraically, for goodness sakes, use your calculator technology. I'm not going to go through how to do that because I really don't want to confuse people tonight. I've already done enough of that. All right, so I don't want to do it anymore. Let me put it that way. All right, so how do we solve this? Well, we do it very similar to how we solved 2 equations with 2 unknowns back in Algebra 1. We use the method of elimination, but we have to do it in stages. Now, notice the first equation is 3x minus 8y plus 2z equals negative 60. And the third equation is negative 6x plus 2y minus 4z equals 36. I'm going to, in fact, label these 3 equations 1, 2, and 3 so that it's a little bit easier to follow my work. Now, what I really want to do is I want matching coefficients that are opposites of each other. And one thing to note is if I multiplied the first equation by 2 on both sides, I'd end up having a positive 6x, which would cancel a negative 6x, and I'd have a positive 4z that would cancel a negative 4z, and all I'd have left would be my y variable, right? So let's do this really quick. I'm going to do equation number 1 times 2. That's going to give me 6x minus 16y plus 4z is equal to negative 120. Don't forget to multiply both sides. And then I'm just going to write equation 3 right underneath it. That's going to be negative 6x plus 2y minus 4z is equal to 36. And the beautiful thing is when I add these 2 equations together, the x's and the z's cancel. I get negative 14y is equal to, I'm going to grab my cheat sheet here, is equal to negative 84, and then just divide both sides by negative 14, and that gives me y is equal to 6. Now that's a little bit weird because if you did enough of these problems in class, you probably noticed that most of the time, you only end up eliminating one of the 2 variables, then you kind of do the same thing to 2 more equations to eliminate the same variable, and you end up having 2 equations and 2 unknowns. In this case, what was very, very strange was we eliminated both the x and the z on our first shot and got y equals 6, which kind of leaves us to wonder, what do we do? Well, what I'm now going to do is if I look at equations 1 and 2, and I just eliminate the z, right? I just want to eliminate z so that I'm left with x and y, and then I could backfill the y and figure out what x is. So if I look at equation 1, I have a 2z, and if I look at equation 2, I have a negative 5z. So if I multiply equation 1 by 5, I'll have a 10z, and equation 2 by negative 2, I'll have a negative 10z, and those will then eliminate. So let's do that as our next step. So I'm going to do equation 1 times 5, and that's going to give me 15x minus 40y plus 10z is equal to negative 300. And then if I took equation 2 and I multiplied it by 2, that would give me 4x minus 14y minus 10z is equal to negative 62? Yeah. Now those z's cancel when I add, and I get 19x minus 54y is equal to negative 362. But the cool thing is I know what y is. Y is equal to 6. So I'm now going to just plug that in, and I'll get 19x minus 54 times 6 is equal to negative 362, right? 19x minus 324 is equal to negative 362. I'm going to run out of room before too long. Oh, I still have some space. 19x is equal to negative, 38 when I add 324 to both sides, divide both sides by 19. Almost always the answers come out to be very nice integers in these problems, and I get x is equal to negative 2. All right, great. Once we have 2 of the 3 variables, so keep in mind, right, we know y is equal to 6, we know x is equal to negative 2, then I can take those 2 values and substitute them into any one of these equations, because then all that will be left will be z, and I can solve for it. To me, because the first equation has a coefficient on z that's positive, i.e. positive 2, I'm going to go with that. But again, it really doesn't matter. So now I'm going to take that first equation, right, which is 3x minus 8y plus 2z is equal to negative 60. And I'm going to substitute in x equals negative 2, y is 6, all I have left is z, right? Combine all of this and I'll get negative 54, negative 6.
Negative 60.
Yeah, no, oh, you're right, yes. Oh, that's negative 60, thank you, negative 60. Thank you, Joey, my producer, negative 2z. Oh, my goodness, is equal to negative 6, and z is equal to negative 3. And red pen comes out for the win. Red pen for the win! And there we have it. Wow. And again, we haven't seen one like this for many, many tests, which probably means on Wednesday it'll be a multiple choice question. Unfortunately. Or maybe fortunately, because how many times do you really want to do this? Still, you know, it is in the standards, so it's fair game. Again, if you know some kind of technology piece that you can use to at least get the answers, that's great. It might involve something called a matrice and a reduced row echelon, but I don't want to go through that right now. All right, let's keep going. Ooh, number 34. In the town of Skaneateles, New York, house prices since 2008 have changed based on the function h of t equals 200,000 times 1.045 to the t, where t is the number of years since 2008 and h of t is the median house price. Determine the average rate of change for the median house price in Skaneateles, I'm probably pronouncing that wrong, and I've lived in New York for like over 30 years now, from 2010 to 2018 to the nearest dollar per year. My apologies to people who live there. Okay, so we have to do average rate of change, right? And average rate of change is pretty simple. Now, one thing that's a little bit key here is that we're talking about 2010 and 2018. T is the number of years since 2008. So what we're looking at here is we're looking at doing h of, what is it, 2018, h of 10 minus h of 2 all over 10 minus 2. Okay, now again, keep in mind, right, that It's h of 10 because t represents the number of years since 2008, and we're talking about 2018, or 2010 to 2018, so 10 years at 2018, 2 years at 2010. Now it's like a real number plugging game, right? I want to put 10 into this function and get a value, and that's kind of ugly, but it is what it is. It's 310,594 to the nearest dollar, which should be good enough. H of 2 is 2,018,405. And then, of course, that's over 8 years. So if I do that calculation, that's 11,523.6, which should be $11,524 per year. So there is our average rate of change. It's just a slope calculation, right? It's the change in the function over the change in time. And therefore it has units of dollars per year. Now they tell us that, the nearest dollar per year. Now, this is a 4-point problem. That's 2 out of the 4 points. The other 2 is here. Explain what this rate of change means as it relates to the median house prices. Now, what does this mean? Well, it means that on average, and I'm going to write this down, the median house price is going up by $11,524 per year from 2010 to 2018. So let's write all of that down. On average, the median home price is increasing. Important. So there's some important words here. On average is important. Increasing is important by $11,524 each year from 2010 to 2018. Now I checked into this because I wanted to make sure of it, right? There are sample responses that the state will put out, and it'll tell you, okay, this got 4 out of 4 points, this got 1 out of 4 points, etc. So they showed one particular answer that had this correct, and that had pretty much this correct, except they didn't include the 2010 to 2018, and they lost a point. And that makes sense, right? Because this function in theory is really good from 2008 on, right? So the average rate of change is really tied to the interval of time. If we didn't do it from 2010 to 2018, if it was from 2008 to 2015, it would actually be a different answer, right? What I'm getting at is it's very critical to include the time interval that your average rate of change applies to. If you don't, they will dock you points. All right, let's keep going. Here we go. Oh, you knew one of these was going to come up. Number 35. A sporting goods manufacturer is trying to determine if they should continue to produce multiple types of hockey pucks. The company surveyed 50 randomly chosen customers and asked them if they purchased both game regulation pucks and lighter training pucks. Of those surveyed, 40 of them said they purchased both types of pucks. Now that word sounds funny to me. A simulation that was run 100 times based on the survey results produced the approximately normal results below. Approximately normal. It's been a while since we've seen that phrase. All right, so let's talk about this, right? This is a simulation where they said, okay, let's assume that like 40% of a population will do something, right? Something. Sorry, not 40% of a population, 40 out of 50, which is 80% of a population will do something. And then we're going to run this thing 100 times, okay, to see what happens. Well, sometimes, right, we have a lower proportion than 80%. Sometimes we have a higher proportion than 80% just by the luck of the draw. right? Just because we're drawing out of a population where 80% of people are going to, buy both a regulation puck and a lightweight puck. All right? Clearly, I don't play hockey enough. And we get these results. A mean, which is very close to the 0.8 or 80%, and then a standard deviation. All right. By the way, this graph in general, not that important. These two numbers, very important. All right, letter A. Determine an interval containing the middle 95% of plausible values that estimates the proportion of all customers who would purchase both types of pucks from the company. All right, this is a very, very common question, the 95% interval. All right, and the key is there to take whatever mean they have and subtract 2 standard deviations from it and adds two standard deviations from it. The reason being that in a purely theoretical normal distribution, about 95% of all data values fall within two standard deviations of the mean. It's not exactly 95%, but it's pretty close, right? So when they ask you to construct the 95% interval, which is pretty much par for the course on these types of problems, you're going to take that mean and you're going to subtract twice this number, and you're going to add twice that number, and that's going to give you a lower bound for the interval and an upper bound for the interval. So let's start by doing that. Here we go. So we're going to have 0.795 minus 2 times the standard deviation, 0.085, and that's 0.625. And then we're going to take that mean, 0.795, and we're going to add 2 of those standard deviations. It's really tempting to add and subtract just 1, but that would only get you about 2/3 of the data, not 95% of the data. And that's 0.965. So then you want to say 0.625 to 0.965. Now, by the way, what that means, right, is that there is, roughly speaking, there is a 95% probability that the true population proportion that would buy both pucks lies somewhere between 62.5% and 96.5%. There's a 95% chance it lies somewhere in that interval. Let's take a look at letter B. The company will continue to manufacture both types of hockey pucks if it is reasonable to assume that the true proportion of customers who buy both types of hockey pucks is above 0.60. Using the interval from Part A, explain whether or not the company should continue to produce both types of hockey pucks. All right, so it's very often the case that they ask us to create an interval and then do something with it. So again, we're going to continue to make both types of pucks, right, if the true proportion is greater than 0.60. Well, keep in mind that there's a 95% chance that the true proportion falls somewhere in this interval, which means that there's only a 5% chance, right, that it falls either below that or above that. So the only way, right, that it wouldn't be above the 0.60 is if somehow it kind of fell below that, the 0.625, and there's a very, very small chance of that, right? So should the company continue to produce both types of hockey pucks? And the answer is yes, because 0.60 is below the entire interval from A. Or you could likewise flip that on its head and you could say, because the entire interval from A is above 0.60, right? Therefore, there's a really good chance, 95% chance or better, that the true population proportion lies above 0.60. Okay, we're getting there, folks. Let's take a look at number 36. Graph y equals f of x, where f of x equals log base 2 of x minus 1 plus 3 on the set of axes below. All right, great. Well, let's do it, right? We're graphing a logarithmic function. We might as well use our calculator. Let's grab that thing out. Let me put in a new page. Let's add a graph. This thing's like, are you crazy? All right, here we go. So I'm going to put in a logarithm function. It's going to be log base 2. Whoops, that almost worked. One more time. Log base 2 of x minus 1. Get out of the parentheses, that's important, plus 3. All right, I'm going to hit enter. Ugh, happening again. Let's make it larger, hit enter. All right, now, that's nice, but we have to actually nail down some values, okay? One thing, though, that this really illustrates is that there is a vertical asymptote, which they're going to ask me about in a little bit, at x equals 1. Whatever makes the argument of the logarithm, the thing inside of the parentheses of the logarithm, equal to 0, is where you're going to have a vertical asymptote. But we still need to get a table of values, some values that we can plot. So I'm going to go into menu. I'm going to try to go into menu. Come on. There we go. I'm going to go into table, split screen table. Notice at x equals 1, it's undefined, right? But then at 2, we have a value of 3. At 3, we have a value of 4. At 5, we have a value of 5, etc. Let me just kind of write those values down. I'm going to minimize this. So we've got x and y, right? I saw at 2, we had 3. 3, we had 4. At 5, we had 5. One thing that we didn't see, but it was on there, 9, we have 6. Now, it is really critical. One thing that they're going to test you on here is that you know that vertical asymptote piece. All right? So we draw our vertical asymptotes in as dashed lines. They're not really parts of the graph. They're like a wall that the graph is approaching. When x is 2, y is 3. When x is 3, y is 4. When x was 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, y is 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 5, 6, and so the graph looks something like that. All right, so that's the first part of this problem. It's important to have those 4 points accurately plotted. It's also very, very important, even if you don't have the dashed line there, that you have this thing bending down and heading towards negative infinity as it gets closer and closer to that line. All right. State the equation of the asymptote of f of x. So you're supposed to know that logarithm functions, all logarithm functions, have vertical asymptotes. And those always have x equals a number equations. And in this case, it's x equals 1. All right, great. So let's take a look at the last part of this problem. It's a 4-point problem. It's got a lot going on. When f of x is reflected over the line y equals x, a new function is formed. G of x equals 2 to the x minus 3 plus 1. State the equation of the asymptote of g of x. Wow, that's interesting, right? Now, for somebody that's taught Algebra 2 a lot, you see this idea of reflecting the function across y equals x, and it's immediate, right? What you produce when you reflect a function across y equals x is you get the inverse function. Now, what's interesting is that they've actually given us everything about the inverse function. They've given us its equation, everything like that. So just for kicks, let's throw that one into the graph as well. Maybe it's not just for kicks, but whatever. All right, one thing I'm going to do is I'm going to get rid of my table for right now. I'm going to remove my table, and I'm going to go into menu, entry. I want a function. One more, let's go 2 raised to the x minus 3 plus 1. And there it is. Let's do that. Let me move this over here. All right, now take a look at that, right? That is the inverse of the graph in red, okay? We could even draw the line y equals x in there and we would see that beautiful symmetry. Now what's cool about inverse functions is literally the roles of inputs and outputs just reverse each other. An input becomes an output becomes an input, right? A y-intercept or an x-intercept here becomes a y-intercept there. And most importantly, a vertical asymptote of x equals 1 here becomes a horizontal asymptote of y equals 1 there. And that's the answer to the question, right? It said, what's the equation of its asymptote? Whoops. And that is y equals 1. And that will always be the case, right? Regardless of whether they're a logarithm function and its inverse an exponential function or anything else, if a function has a vertical asymptote, its inverse will have a horizontal asymptote simply with the variables changed. All right. Here we go. Last problem. Love the sound of that, right? Part 4. Let's go one more drink of lemonade and then we'll get into it. Lovely. All right, just what I need right now. Now, part 4 problems, whether we're talking about Algebra 1, Geometry, or Algebra 2, are 6-point problems, often very, very involved, and this one is no exception. So let me make it a little bit bigger. Hopefully, there we go. And let's take a look at a Newton's law of cooling problem. Megan is performing an experiment in a lab where the air temperature is a constant 73 degrees Fahrenheit, and the liquid, I love the liquid, it's coming out of nowhere. The liquid is 237 degrees Fahrenheit. I wish they would have said is initially 237 degrees Fahrenheit, but we're going to forgive them. 1.5 hours later, because we have no choice, 1.5 hours later, the temperature of the liquid is 112 degrees Fahrenheit. Newton's law of cooling states that T of T equals T sub A plus T sub 0 minus T sub A times e to the negative kt, where T sub T is the temperature in degrees Fahrenheit of the liquid at T hours, T sub A is the air temperature, T sub 0 is the initial temperature of the liquid, and K is a constant. Determine the value of K to the nearest thousandth for this liquid. All right, so this is actually really cool, right? And like kind of a little bit of the physics of it, right? Newton, Newton, who we all know and love, right, came up with the theory of cooling liquids and basically said, look, if you take a liquid that's at a temperature that's above the room that it's sitting in, then it will cool down. All right, and it will cool down according to an equation that looks a lot like this, right? Where this thing is T sub A is the air temperature, right? And that's going to be 73 degrees F, okay? T sub 0 is going to be the original temperature of the liquid, in which case that's 237 degrees Fahrenheit. T sub A is still the room temperature, that's still 73, right? E is just the number E, and negative K, and that negative's there so that we get a decrease in the temperature of the liquid, times T. And they want us to figure out what the value of K is. The first thing that you want to do in a problem like this is just put everything into this equation that you know that are constants. So let's do it. Here we go. I'm going to have T of T. I wish there was some way that I could say that differently, but there isn't. All right, the air temperature, which is, whoops, not 237, that would be crazy. That would be a problem for Megan. 73 degrees plus the original temperature, 237 minus 73, times e to the negative kt. All right? Now, one thing that I would definitely suggest in a problem like this is don't leave this number like that. That's just silly. So I actually do the subtraction, and you get 73 plus 164 e to the minus kt. Okay. So that is our cooling model so far. And by the way, if you will, just like what we had in the other problem, 73 is a horizontal asymptote. In other words, right, the temperature is going to be cooling down and leveling off, getting closer and closer to 73 degrees as it cools down. But we need to figure out the value of K to the nearest thousandth, 3 decimal places. How do we do that? Well, we need one other point on the cooling curve, if you will. So what do we know? We know that 1.5 hours later, the liquid is 112 Fahrenheit. So in other words, at a time of 1.5, we have a temperature of 112. And that's all we're going to need to figure out the value of K. So let's do it. I'm going to put 112 in. I'm going to try. There we go. Oh, come now, come now. There we go. I'm not doing anything to the board right now. I'm going to put 112 in for T of T. 73 stays, 164 stays, and then I'm going to have e to the negative k times 1.5. All right, I'm going to rewrite this just a little bit. 112, 73 plus 164 e to the negative 1.5k. All right. Now, I don't know if you remember this, but a long time ago in a part 2 problem far, far away, we actually solved an exponential equation that wasn't too much different from this, right? What are we going to do? We're going to subtract a 73 from both sides. We're going to divide by 164. Then we're going to take the natural logarithm to get rid of the e, and then we're going to divide by negative 1.5 to get rid of that. And we're going to have k. So let's do it step by step. All right, first things first, minus 73, minus 73. That's going to give us 39 is equal to 164, e to the negative 1.5k, divide by 164, divide by 164, right? Gives me e to the negative 1.5k is equal to 39 divided by 164. Just like that part 2 problem, I would suggest not evaluating that fraction. Take the natural logarithm of both sides. That cancels the e out. We get negative 1.5k is equal to the ln of 39 divided by 164. And then divide by negative 1.5 on both sides. And let's do that real quick on the calculator. Let me put in one more page. How many pages do I have now? A ton. 9 of them. So I'm going to have, here we go, the natural logarithm of 39 divided by 164, and then all of that divided by negative 1.5. And k is going to be 0.9575, etc. Right, very small here. You just make it a little bit bigger so that you can kind of see all of that. Right, and again, the beautiful thing about not evaluating any of this until the end is we don't introduce any rounding errors. Now remember, they said they wanted it to the nearest thousandth, so we have 3 decimal places, and that's going to be 0.958. 0.958. All right, let me just minimize that, get rid of that. K is 0.958, and there's our value of K. Now, you got to be a little careful here. K is positive, but there's a negative built in to the model. And I know that that's a little bit difficult to see because of the weird zooming that there we go, I hope that's right, yeah. So there's a negative built into the model, and there must be, otherwise we wouldn't have the decrease, right? So let's now move into the next part of this problem. Determine the temperature of the liquid using your value for K to the nearest degree after 2.5 hours. So, this is really a pure plug and chug part of the problem. But I think that they put it in there to make sure that you understand what the model is at this point, right? The model at this point is the following. T of T, come on, T of T equals, gotta get the right sheet here, 73 plus 164 e to the negative 0.958 t. So that's our model, right? We want to just know after 2.5 hours, I love how they have to keep writing that out. So t of 2.5 is 73 plus 164 e to the negative 0.958 times 2.5. And yeah, that's a little ugly, but let's throw it in there. 73 plus 164 times e raised to the negative 0.958 times 2.5. All right, so to the nearest degree, and let me make that a little bit bigger so you can see it, to the nearest degree, that's going to be 88. Now, by the way, right, one thing that I could easily see a student forgetting to do in this is to put the negative back in. They might think, well, k was positive, so it's e to the positive. But if you did that, right, if you forgot the negative, right, and you did it that way, look at what the temperature of the liquid would be. Now, don't get me wrong, liquids can heat up, right? But this is very specifically a Newton's law of cooling problem, right? So it would be very, very weird to take a liquid that was 237 degrees or whatever it was at the beginning, right? Put it in a room that's 73 degrees, let it cool down, and after 208 hours, you know, you've got a temperature that's like almost 2,000 degrees. I'm not even sure it would be a liquid at that point, but then again, I don't know what liquid it is, so who knows. Anyway, so always make common sense if you can, which isn't always possible, out of your answers. All right, final part of final problem. Here we go. Megan needs the temperature of the liquid to be 80 degrees Fahrenheit to perform the next step in her experiment. Use your value of k to determine, to the nearest tenth of an hour, how much time she must wait since she first began the experiment. All right, so you know, I originally worked this all out algebraically, and you can certainly work it out algebraically. But then I thought to myself, you know, the algebra to do that is actually very, very similar to this algebra. It's very similar. The big difference is that instead of solving for k, you're solving for t. We could certainly do it that way. But there's absolutely nothing in this problem, nothing at all right here, that says you have to do it algebraically. So I think that this is a wonderful time to actually do it graphically. Because really, what are you doing, right? You're actually trying to solve this equation. Right? We're trying to solve that equation. So what makes sense to me is to graph this in one function, graph this as another function, and see where they intersect, right? I mean, this is just the temperature of the liquid as it cools down, and we want to find out when it's equal to 80. So let's get a graph and find that out. So one more calculator screen. Here we go. Let's add a graph. Why not? Make the thing big to begin with. And here we go. 73 plus 164 e raised to the negative 0.958 x. That's fine. Hit down arrow. Hit down arrow again, apparently. And now 80. Enter. Now, of course, you look at this and you're like, okay, well, that was a complete bust, right? I don't see anything. And that's because my scales are so off, right? Now, my x scale might be okay, right? We're talking about time in hours, right? And it goes from like -10 to 10. I certainly don't need the negative time in here. But the y-axis is all off, right? It goes from like 0 to 6.67. But we're talking about temperatures that, you know, started off like in the 200s, and now we're trying to figure out when it's equal to 80. So we have to adjust our window. So I'm going to go into Menu. I'm going to go into Window Zoom, Window Settings. I don't see any reason to have negative x's, but I'll do like -1 and, you know, 10 for whatever reason. That seems fine. I'll put a little negative y in there, but, you know, let's go up to 300 here, right? And there they are. You know what I don't like? I don't love having a grid on right now, so I'm going to turn my grid off. Okay. And what we can certainly see, even though we might have a little bit of mess here, is the red curve, right? That's my liquid, my cooling liquid. Okay. And it's got an asymptote at 73. Not that that matters. And that horizontal line is the 80-degree mark. And what I want is this intersection point. So let's find it, right? Let's go to Menu. Let's go to Analyze Graph and Intersection, which is maybe the most important thing that I use on my calculator in terms of graphical stuff. I'm going to enter, slide it over, enter. And my intersection point is at 3.29, 80, right? So I'm looking for to the nearest tenth of an hour, how long she's got to wait, and that's going to be 3.3 hours. Now, what kind of work do I have to show to get full credit here? Well, let's do it. Let me minimize this. And what we want to do is we want to just have a really good but basic graph, right? We want to have our scales labeled. So for me, I was at 310. So here and there. And then we have this curve that went like this, and that was T of T is equal to 73 plus 164 e to the negative 0.958 t. And then we also had y equals 80. And then we had an intersection point, which was 3.29, 80. And therefore, t equals 3.3 hours. That's it. You can definitely do this algebraically, but the algebra is nearly identical to what we did in the first part of the problem, right? So I didn't want to kind of reiterate that. And it's a prime example of when I actually think a graphical solution makes a lot of sense. You know, you can see the liquid cooling curve. You know, you can see that horizontal line that we have to reach before she can move on to the second stage of her experiment, right? And we can then easily find the intersection point. And that concludes this test. So let me kind of go back up to the beginning. And let's wrap it up, right? So, you know, Algebra 2 is unquestionably the hardest of the 3 Regents math courses and the hardest of the 3 math Regents exams. There's no getting around it. There were some very challenging problems on this test, especially some very tough part 2s, right? Where you have to do a lot of work just to get 2 points of credit, all right? Keep in mind, as I always say on all of these exams, don't forget you've got 3 hours. Now, that's not as much time as it is for the geometry and the algebra. Actually, it's the exact same amount of time. But the exam is harder, so you'll take up a greater proportion of that time working on this exam than you probably did for Algebra 1 or for geometry. But you will still likely have excess time. So make sure to go back and check things over. Use your calculator in innovative ways. Don't forget about how you can solve equations graphically. Don't forget about that store command. Man, is that useful on your calculator to do so many different things, right? Keep in mind fundamental ideas like factoring and zeros and polynomials and roots and all of that. I know that you have been thrown a lot of information in this course, and we reviewed only a portion of it from this exam. But I'm confident that if you were really with it this year, you were paying attention, you were engaged, you were doing your homework, and you've joined me for this review, you can get through this exam, you can thrive on it, you can even, get distinguishing marks on it, right? Which is like an 80 or an 85 and above. I don't really know, all right? But you can do well on it. Just have faith in yourself. Get a good night's sleep on Tuesday night going into Wednesday, eat a good breakfast on Wednesday morning, right? And have confidence in yourself. Believe that you can do well on this, and you will. I apologize again for the power outage that we experienced about halfway through that, ended up having having us now having 2 Algebra 2 videos. Unfortunately, there's nothing we can do to control the weather outside and the thousands, if not hundreds of thousands of air conditioners running right now. But it does look like we made it through to the end. So I want to thank you for joining me for the E-Math instruction, Algebra 2 Regents Review. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.